Good morning, this is your Stat Sensei, Mr. Sensei, and this is some notes on harvest time and the t-test, specifically for a hypothesis test. The Ministry of Agriculture is interested in examining possible changes in the time to harvest sorghum in a region where it's been introduced. Past studies suggest that under similar conditions, times to harvest is 100 days and is normally distributed. To examine whether the mean time to harvest has changed. By the way, we're talking about changed, and they're seeing whether it was different. I don't see it now. Um, when I say that, that lets me know that I'm looking at probably a two-sided hypothesis test, two-tailed. So researcher collected a random sample from 15 fields, so we know our sample size is 15. And we know that in previous it was 100, so we're going to assume that that's their claim, 100 days. Um, and there's more than 3,500 fields, so we have a large population, so the sample size is less than 10%. The results are shown. The results are as follows. Okay, so here we go. We have this list and conduct a test to determine whether harvest time has changed. And so once again, there's that word change. So that tells me, hey, we're working with a two sample t. So with that being the case, we're going to need our formula, which is t equals x bar minus mu s divided by the square root of n. And I'm going to go ahead and enter that data into my calculator. So I have it all into stat edit. There it is. So I went to stat edit, it's in L1, and then I went stat calc 1 var stat, and I get my sample mean of 107.666 and a sample standard deviation of 8.1034. Looks like we have a little bit of a typo here. And because we're using the sample standard deviation, this makes this a t-test. When we know our sample size is 15 and we know the claim is, in this case, 100 days. And technically, this is also days. So we're going to run a one sample t-test for mean. So that's what we're going to run. Now, whenever we run a hypothesis test, we're always going to be centered on the mean. And in this case, our mean was 100. So we need to be centered on 100. And in this case, we have an X bar of 107.66, which is above. So technically, even though we're above, we still, because we are working with the not equal, this is still going to be a two-sided test. And so we need to circle two-sided. To that point, we can go ahead and plug in. We have our sample mean minus our population mean divided by, and once again, this looks like I think this is a typo, 8.1034. All right. And the null hypothesis, our mean is 100 days. And our mean does not equal 100 days. So at this point, let's go ahead and run this thing. We're going to go stat test t-test. Mean is 100. Our data is in L1, so that's all good. And if you didn't have L1, you're going to press blue followed by the number 1. Make sure not equals highlighted. We're going to press calculate, and we get 3.66. Now that's a positive 3.66, which makes sense because we're above the mean, and there's all of our information. So this needs to be a 2 times out front. Don't forget that. Anytime you're working with a not equals, it needs to be 2 times. And we have 0.00255. So this is 0.00255. And this is 0.00255. And that's less than the 500. So we're going to reject the null. All right. So that's our decision on this one, is to reject the null. Couple things to make sure of. If it's two-sided, Make sure you put a 2 times out front and 0.0255. All right. And anytime it's less, our p-value is less than alpha, it's 0.05. Now they didn't give us an alpha. If they don't give you an alpha, just assume that alpha is 0.05 if one is not provided for you. All righty. Appreciate you watching and hope to see you on the next one. Thank you.